Welcome everyone. In this video I'll go through lab 1 that we've already done in the class. So right now I'm logged into Sakai. I put my user ID and password and log into that. I go into resource, and in resource you're going to find out the particular lab that we're going to go through, that is rlab1.r. So just click onto that. It will open in the web browser, and now I will go through each step the way I went into the class, and in case you were not there in the class or you could not follow, you just pay attention to these steps. Okay, so everything will be executed in R. So the way to start R is go to start window and type R Studio. So once I do that, R Studio comes up and you will see 4 windows in there. This is the window for the script, and this is the window where you execute all your statements. Whatever you execute in this particular window console over here will be available in the history. So in case you execute a statement and you want to rerun that statement, all you have to do is to select that particular statement and then send it to console by clicking over here. And whenever you're generating any kind of plots, those plots would be available over here. So if you generate, say, a histogram or a scatter plot, that plot will be created over here. So that's a brief introduction of RStudio. And if you want to install RStudio, I'll show you another video, how to install RStudio. For installing RStudio and making it work, you need R before that. So I'll go in that detail later on in a different video. So now let's go back to our script that we have to do for the first lab. Now the first statement that we have to execute is ls parentheses open parentheses closed. And one thing before we get deep into this script, this hash sign over here means comments. So in R, hash sign means comment. These lines will not be executed. They're just for comment, just to communicate to you. I put them with hash sign. So ls doesn't have any hash sign. That implies that it's a command in R. And what ls does is it gives you all the variables that you have worked with or you have created in your R session. So Apple is one of the variables that I've created in my session. If I create another variable, now V is a variable that I've created, and now if I do ls again, I will see V in there. So V and Apple both are sitting in my computer's memory, in my laptop's memory. So whenever I'm working with anything in R, these variables are being created by me. These variables are sitting in the memory. ls is a way to see, okay, what's a variable name, what is there that is sitting in my memory, because memory is finite. It could be 4 GB or 8 GB. Depending upon which laptop you have. In my laptop it's about 8 GB. That's a finite resource, so you want to conserve it as much as possible. So if you want to remove all the stuff that is there, or some of the variables that are there in your memory, you can do it with a very simple step called and this will remove everything which is there in the memory. So if you do this command once again, you find nothing in there. So character 0 means there's nothing sitting in your memory. So far so good. Okay, now let's go to the next step. And the next step is setting working directory. So whenever you work with R, you want to have a working directory where all the files that you create, all the files you want to read into R will be stored. That's called working directory. As the name itself sounds, this is the directory you'll be working out of. So the command to do that thing is called setwd. WD stands for working directory. And in between these double quotes, you type exact location where you want your working directory to be. So I want to make it to be my desktop. So I go to my desktop, and there's a folder called LAB01. One folder called LAB01, and it has certain things in there. So what I'll do is I'll delete this LAB1 and I'll create a new folder called LAB1, an empty folder called LAB1. So I'll create a new folder and I'll call it LAB01. So that is fine. I'll get the location of this folder by right clicking and going to the property of that particular item. So in this case LAB01. All you have to do is to give a right click, go to the property and highlight this whole thing, location, copy it, go to our session and paste this, and then LAB01. That's a folder you have just created. Now if you just execute it like this, it'll give you an error because these signs right over here is not recognized by R. So in order for this thing to work is change the direction of this slash, make it this one, and this slash is right where the question mark is on your keyboard. So once you do that, now your working directory is set to LAB01. So if you do say list.files, you can see all the files which are there in the working directory. Because I created this directory only a couple of seconds ago, there is nothing in that particular folder, so that's the reason there is nothing. Return for list.files. Now if I want to find out which is my working directory, I do not know, I set it a long time ago, or I just started my R session and I just want to know where to put the files. All you have to do is to type this function called getWD, parentheses open, parentheses closed, and this will give you the existing working directory. So right now the existing working directory is desktop LAB01 folder. So set working directory is a way by which you set a working directory where all your files going to be stored which you want to read. All the files that you generate out of your R session, you write those files, they'll be sitting in working directory. Okay, set WD, get WD, we have done both of these. Now let's go to our tutorial. Okay, so now we're done with set WD and get WD. Let's go to the next step, and that is to read data into R. Now R is a statistical tool. It doesn't have a data of its own. Data is huge these days. About 10-15 years ago, if you had 10 GB of data, that was a lot of data, but today you have terabytes and terabytes of data. So the way data is stored today in any serious corporation is, or business entity is, in database. So data is sitting in database, and then maybe you'll read the data out of the database in a flat file if it's really small, or you will make a connection to the database and then read the data. And then in R, you will do all the statistical analysis. So let's see one example where we read the data from flat file. So let's go over there and copy this command, flat file. So what I'm doing over here is I'm reading this particular text file, lab01.txt, that is sitting in my working directory. This file is separated by pipe. So those who haven't seen pipe symbol before, it is right above enter key on your keyboard. So if you look at enter key on a keyboard, you'll see one key which has backward slash. Right on top of that you have pipe. So press shift key and then press that key and you'll get the pipe symbol. But all it's saying is that in LAB01 the columns of that data are separated by pipe, and then the header of that particular file is there, it's present, and that is what we mean by header is equal to true. So let's examine that file. So let's go to Sakai, and that file is already there over here. So let me download that, right click, do save as, and then let's go to the folder that we created. It's LAB01. So it's right over here. I do save as, and the file is downloaded. And let me do the same thing for LAB02 as well. Okay. So both the files are saved. If I just click them here, they'll open in web browser. All I want to do is I want to look at this file. So one thing that I realize is while looking at this file is that it does have header. So that's the reason why I put header is equal to true. Another thing about this file is that this is my first column, serial number. The second column is income. And these two columns are separated by pipe. And that is what I mean by pipe over here. So I'm reading lab01.txt, the columns are separated by pipe, and the file does have header. That's all it's saying. It will read all the data which is there in this particular file, lab01.txt, and it will put this into lab1 variable. Now those who are new to programming language, variable is nothing but it's a label. It's a name that you give to say all the data which is there in this file. So I do not have to keep saying that give me the data or do this particular operation on the data in the lab01.txt. All I have to do is to call this name called label lab1. It's a label. It's you can think of that as a container. It's a container that holds all this data. I do not have to deal with the data by its name or by all these verbose commands. All I have to do is to give it a name, and once I call the name, R knows that I'm talking about all the data that's sitting in the text file. So that's what at a very basic level variable does. So now once I've written this, I will enter keystroke, and all the data from lab01.txt is read and it's put into lab1 variable. So this is how we read the data. Now let's go to the next step. We'll do the same thing for lab02 .txt file. So both the files have been read. One is put into the variable lab01, another one is put into lab1 and lab2. Okay. Now the data is sitting in these variables. I want to examine the data. How to do that? There are multiple ways of doing that, but the basic way of doing that in R is examining the data in R is using a function called head. And if I do head lab1, it will return first 6 rows. Head means top rows. So by default, it will give me 6 top rows of the file lab01.txt, because you remember lab1 has is just a container, just a label which contains all the data that is there in lab1_1.txt. So these are the top 6 rows of file lab101.txt. Okay. Now I want to not only look at top 6 rows, I want to look at top 10 rows. So the way to do that is you can give an extra parameter. It's called n, and you can make it 10. And now you can see the top 10 rows of lab1. Lab1 is nothing but that file that we read into it. Similarly, if I make it 20, I will see the top 20 rows of that particular file. And the whole purpose of the exercise is to examine the data for the first time. So you got this file from somebody from your data warehousing team, and you load it into R and you want to examine the data. So you start looking at first 10 or 20 rows, and then you'll spot some issues or errors and the structure of the data. All you can make out from those top rows. In case you're interested in the bottom rows as well, all you have to do is to change this head to tail, and it will give you the bottom 10 rows, so 20 rows in this case. So these are the bottom 20 rows of that file that we read into lab1. And similar kind of operations we can do on lab2 as well. The point is, you read the data, it's sitting in the variable. Now with tail and head, you can see the top certain rows and bottom certain rows, and very quickly you can find out how the data is distributed, how many columns are there, is there an issue with the data, do you have all the variables that you asked for from your data warehousing team. All those kind of very basic things you can do out of head and tail. So that was the point. Now here one thing, and maybe I'll repeat that multiple times, if you want to find any help on any of the functions in R, all you have to do is to write a question mark and then say head, and we'll open up help on head function. Similarly, you can do the same thing on the tail. In this case, head and tail documentation is exactly the same because they're doing exactly the same thing. So if you do tail, it'll give you all the information about tail. So default method n is equal to 6l will give you the 6 rows. If you want more, it can give you more rows, and it has all the documentation about these functions. So you can do that on any of the functions that we'll talk about in this class or in later classes. Okay, so far we read the data into variables. We did head and tail, everything looks great, but now I want to summarize the data that I've read. I want to see the basic statistics on that data. I want to see the spread of various numeric columns, how to do that in one go. And that's where summary helps. So write summary and then the variable on which you want to find the summary. So here I get a summary of all the data that is there in lab1 variable, which is nothing but the data that is in lab01.txt file. So here is the first column, serial number. The minimum of serial number is 45, the maximum is 9999998, and the mean and the median is 499499. And just by looking at this and looking at the top row and the bottom rows through head and tail command, we know the serial number is nothing but a bogus number that is system generated. It is unique for each row. That's all it's doing. There is nothing spectacular about this data. Now, income, on the other hand, is kind of interesting variable. It has minimum of 4 and the maximum is 1620560, so that's a huge number. If you look at the median, it's 50300, so that is low as compared to say mean 67152. So that tells me something about the skewness of the data. I also look at the first quartile, which is $26,000, and then the third quartile, which is 84,200. So majority of the data is sitting in that interquartile range. 26,000 minus 84,200. That's my IQR. And then I look at the rooms. So it seems like there are only like 9 values for the room. The minimum is 1, the maximum is 9, and the mean and the median is kind of close to each other. But the point is, with summary, you can find a lot of things very quickly. Okay, so that was about summary function. Now, once I realize that serial number doesn't bring any value to me, what I can do is I can remove serial number, and that way I'll be left with only those columns which are useful. Now, through our data mining, our focus is that there could be like thousands of variables, and we cannot spend our energy on thousands of variables. So all the time we are in this business of removing those variables which do not bring any value to us. So in this case, I want to remove serial number. How to do that? The way to do that is through the statement lab1 square bracket open, and here is a square bracket close. In between there's a comma and then 2 to 3. What that means? What that means is, so lab1 you already know it's a variable. Now square bracket, that implies give me a subset of the data that is in lab1, and there are 2 parts to it. One part is before the comma and the other part is after the comma. Before the comma is which particular rows you are interested in too. If you leave it blank, it will give you all the rows which are there in your variable. In this case, it's a data frame, and we'll talk about it later on. And the second one is for columns, which columns you're interested in too. So the pattern is RC, remote control. The first variable over here, R, before comma tells you which rows you're interested in too, and after comma tells you which columns you're interested in too. Okay, so here I have left the value before comma empty. So that implies I want all the rows which are there in lab1 variable. And then after comma, I'm saying 2 to 3. So give me all those columns which are between 2 and 3. So there are only 2 and 3 columns. So I'm interested in this one, which is second, and then room, which is third. So all I'm saying is, okay, from lab1, give me all the rows because this thing is empty, and give me only 2 and 3 columns. Give me income and give me room, and put all that data into this variable and lab1. That's all this function is doing. And once I hit enter, all that information is stored in nlab. So nlab now has only 2 columns, income and room, and the serial number is not there. So if you do summary on say nlab1, you're going to find out only income and room as columns. However, if I do summary on lab1, I got 3 columns. So this is the way by which I got rid of column 1, because I'm only interested in column 2 and 3. Okay, so that is what that step meant. Now let's go to the second step. So I got LAB1, and in this case I did a summary and I found that okay, there are two columns. However, whenever we get a data frame or we read a file or we make a connection to the database, we are interested to how many rows are there and how many columns are there. They're called dimensions. Okay, so how to find out dimension of a variable in R? So all you have to do is to issue this statement called dim, D-I-M, which stands for dimension, and after that put the name of the variable. In this case we're going to put nlab, and will tell us there are two columns in there and 120,530 rows in there. So once again, the format is RC, remote control. This one stands for rows. That many rows are there in this frame, and this stands for column. There are only two columns in there, so that is fine. Now let's do the same thing on LAB1. Number of rows will remain the same, however the number of columns is going to be 3, because when we created nlab1 we removed one of the columns, that is serial number. Okay, along with that what we can do is we can look at what type of elements are there in nlab1. So let's do this, and it says list. And why it's saying list when I know that elements are actually integer? That's a question. The reason for that is that nlab is a data frame. Data frame is a data type which I talked about in class 1 or in first slides. Just look at those PowerPoint slides. Last 10 slides or so are dedicated to basic R statements and commands. So there I mentioned that data frame is a kind of data type. So whenever you read anything from database connection or read it from file, the default data type is data frame. Okay, so just to prove that point, you can issue another command called class, which gives you the data type of a particular variable, and in this case the data type is data frame. So one thing out of this is that whenever you read from connections like database connections or out of say file, the default object type is data frame, and data frames are composed of list. Okay, so far so good. So let's do one more thing. Let's do something called correlation, which you must have gone through in statistics class. It's a very common thing. How to do correlation between various columns in a data frame. So it is as simple as issuing a command called COR, which stands for correlation, and then you have to give the name of the variable which has those columns. So in this case let's use nlab1, and now it gives us a correlation matrix. Here is a intersection of income and income, which is of course 1 or 100% correlation. Now here is a intersection of room and income, which is 38.2%, not that strong correlation. Here is an intersection of income and room, it's 38%, again not that great a correlation. But this is the way, a very simple example how you can run functions like correlation and you can calculate the correlation amongst various variables in a data frame. Okay, now if you want to remove all the variables that we have created in memory, you can do that with a command called rm. I think we've already gone through that, but rm is a way by which you can remove all the stuff that is sitting in your working memory. So in order to see what is sitting in your working memory, as simple as that, ls, which we've already gone through, that was the first statement, and gives you everything that is in there. So what we are interested into is only nlab1. So I can remove lab1. So lab1, and once I do that, lab1 is gone. If I do ls once again, all I see is lab2 and lab1 is still there. Okay, so only two things are there. Previously there were three things. Now what I do is I can rename my nlab, or I can create a new variable by this statement. Now here I'm using, instead of that this sign, I'm using equal sign right over here. They're essentially the same. I tend to use equal sign more often because that's easier to type, but they're essentially the same. Now lab1 and nlab1, they're exactly the same. I created a new variable lab1 with this statement over here. So if I do ls right now, I'm gonna see three things in there: lab1, lab2, nlab1. nlab1 and lab1 they're identical. Okay, because I just created lab1 by reading all the stuff which was in the AND lab and putting it into lab1 variable. Okay, now if I want to save everything that I have into a file so that I could load it later on, or maybe I can save it later on for some other purpose, I can do this command. It's called save, and I can specify which particular variables I want to save and which particular file. So here I will say, okay, save lab1 and lab2, and the file is going to be labs.r data, and this file will be saved in my working directory, which I set in set working directory command. So let's enter this, and now all the stuff is saved in lab.r data. So if I go into my working directory, which is lab1, so here's lab1, I see this particular file sitting over there. So that's labs.r data, which I just created out of this statement. So this is a way by which you can save your variables in a file on the disk, and if you want to use it later on, you can use that later on. And I'll show you a command which I have already given to you in the first class, in the first slides, and its command is called load. So so I'll give you that. Now let's go to the next step. Okay, now so far we just saw like you can remove one variable at a time, but you can remove multiple variables at a time. So here I'm removing lab1 and lab2 because I've already saved them on the disk. I can do that in one go just by putting them separate by comma, give it an enter, and they're gone. So now if I do ls, all I want to see is then lab1, because lab1 lab2 is gone. Okay, so that is done. Let's move on to the next step. And the next step is how to remove all the stuff which is there in the working memory. I think I've already shown that. All you have to do is to issue this command rm list is equal to ls. So all this command is doing is it will do ls, which will give it all the things which are there in your working memory. It will assign that to list variable, and then rm will go after all those things which are there in that list, and will destroy all those things from the memory. So once I do that, now everything is gone and no lab is there, no lab1 or lab2 are there. So all the things are cleaned. It becomes really handy when you have like hundreds of variables you have created and just want to get rid of all those things. Start with a clean slate. Okay. So we are done with that. Now let's go to the next step. Okay. So the next step is how to create variables in R. We've already seen how to create data frame, which is by reading data from file, but you can also create, say, scalar variables. So the way to do that is we go over here, n is equal to 1, and now n is a scalar variable. It is of numeric data type, and if I call n, so you see it's the 1 is right over here. Now one thing that I mentioned in the class multiple times is that almost everything in R is vector. So even though it's a scalar, it has only one element in it, still it's a vector, and that is what is meant by the square bracket over here. All it's saying is that the first position in this vector is 1, but that is the way you implement scalar variables in R. Okay, now similarly I can create strings as well. So here let's go and create a string. So here I have a string, Loyola University Chicago, fall 2015. It's surrounded by double quotes, so be cognizant of the fact that you need double quote. Without double quotes, it'll give you an error. So let's see, like if I do double quote without double quote, what can happen? And I get an error. Okay, so it has to be double quotes to show or tell R that this whole thing is one string. So let's enter, and now the entire string is stored in S. So if I call S, it'll show me this whole thing surrounded by quotes, which means the string, and this 1 means that even though S is storing a string, it is actually a vector, and in this case it has only one element, which is Loyola University Chicago, fall 2015. So as simple as that, you can create scalar variables, you can create string variables just by assigning numeric or string inputs to respective variables. Okay, now let's create some vectors. So the first example that I did, and let me copy all these because all of them are vectors. So here I got a bunch of vectors that I'm creating over here. Levels is the name of the variable which will hold this vector: worst, bad, mediocre, good, awesome. And then the C stands for combine or concatenate. So the C is combining worst, bad, mediocre, good, and awesome, which are of course surrounded by double quotes because they are strings, and they're separated by comma, and they're combining together into one vector. It's called level. So if I do levels, I'll get, you know, worst, bad, mediocre, good, and awesome. Worst is the first element, and this is the second, this is the third, this is the fourth, and this is the fifth. So that is what is meant by that. So if I increase that to like 20, and let's assume that this line can only go like 10, so 10 will be in the first row, and this will show like 21, 11, and then other 10 from 11 to 20 will go in the second row. So this is how our window works. So there were some questions in the class. People were saying, you're seeing 1 over here, but I see 3 over here, 1 here, and 3 over here. Why it's different? It's because of the window size. If you make it long enough, then it will fit everything in just one row, and then you'll have just like 1 over here. But if this whole string is splitting into multiple rows, in that case you're gonna have 1, then 5, then 10, then 15, that way. Okay. So all these variables are created. The construct is very simple. Give the variable name, and then equal to sign, or this particular sign. Assign it the value based on what is there in this parentheses over here. So now this level vector has 5 elements: 1, 2, 3, 4, and 5. Similarly, I create a vector called rating. I create another vector called critics, another vector called movie, another vector called attendance, and then reviewers. And this is the data that is related to movies. There are only that many movies in there, 1, 2, 3, and 4. So 4 movies are there, and then there are 4 critics are there, and these critics are rating all these 4 movies. So data is all about that. Okay, so this is the way you create vector. You have to use C as a way to combine the elements of the vector. Then parentheses open, parentheses close. In the middle, you're going to have all the elements of the vector. If those elements are numeric, like in the case of attendance, you do not need the double quotes. If they're not numeric, you need the double quotes. So be cognizant of the fact. And each element is separated by comma, so do not forget that. Okay, let's go to the next step. So the next step is that we create a data type in R called factor. So factor, those who are in computer science, factor is like associative array. Those who are not into computer science, factor is a way by which R depicts categorical variables. So categorical variables like rating, worst, worst, bad, bad, good, bad, bad, right over here. It's a categorical variable. According to this vector, it has 3 levels: worst, bad, and good. So every categorical variable has 2 elements. One is, of course, the data itself. So in this case, it got 1, 2, 3, 4, 5, 6, 7 entries in there. So that's the data. And the other thing is the level. So the level is, there are 3 levels in there: bad, good, and worst. And that is what we mean by factor. So factor has 2 components. This is the data part. So first, the data part gonna come, which is the ratings vector right over here, because that has the data. And then the levels part gonna come, which has all the distinct values of that category. And once we enter that, and levels over here has 5 levels based on the vector, the first vector that we created. Besides worst, good, and bad, it has mediocre and awesome. So now we got we created a factor which combines all this information. If we do F, it will tell us there are 1, 2, 3, 4, 5, 6, 7 elements, or 7 pieces of data in there. And in this category called F, there could be categorical variable called S. There could be worst rating, there could be bad rating, there could be mediocre, there could be good, there could be even awesome. Although we do not see any awesomes in there, but it's a possibility. Now, if I do table on F, I find, okay, there are 2 worst ratings out of the data that I've fed into the factor. There are 4 bad, there are no mediocres in there, there's no awesome, and there's 1 good. So table is a way by which I can create a single way contingency table. It works on factors. It also works on data frames. We'll see that later on. But that's what table does. You can create a single way contingency table, a frequency count table on a given categorical variable just by 1 click. Table and give the name of the categorical variable, and boom, you'll have all the counts for each distinct value of that categorical variable. Okay, so that is all done. Let's look at an example of how to create a list. Okay, so list, the way to create a list, and I mentioned in my first lecture PowerPoint slides what a list is, but those who missed that one, list is very similar to a vector. The only difference is that in vector, every element doesn't have a name. It doesn't have, there's no way to give a name to the vector, to the element of the vector. So there is no name for Siskel over here, Siskel over here, Ebert over here, Ebert over here. So there's no name. All they have is position number. That's all they got. But in a list, every element has a name. So here, ratings is an element. It has a name called rating. Here, critics is an element. It has a name called critics. Here, attendance is an element and it has a name called attendance. And here, movie is an element. It has a name called movie. So we do like that. And now we want to see this. And we see the entire FL, which is nothing but a list. And we see, okay, rating is the first element. That's what is meant by here. And it has worst, worst, bad, bad, bad. And then, so rating is the first element. Critic is the second element. It got 4 elements over there. Movie is another element that is defeated. Snake on plane. Encino Man, Casablanca. So there are 4 elements in there. And attendance is there. The great thing is that you got all these pieces of information which are related to each other. You can put it in one variable, and then you can do a lot of gymnastics on top of that. So, but the great thing is you can combine everything in one go. In one variable, you can combine a bunch of variables in a very related way. So that was an example of list. Now let's move on to the matrices. The way to create matrices in R is very similar to creating a vector. However, you got 2 things. One is, of course, you have to specify matrix, just like you have to specify list or factor for creating a factor or list data type. And then it's followed by a vector, the vector of data that you're going to be putting into the matrices. And thereafter, after comma, you have to specify how many rows are going to be there, how many rows going to be there in that particular matrix. So in this matrix, I'm going to be having 2 rows. And how many columns going to be there? So in this case, there will be 3 columns. So 2 by 3, so there are 6 elements in this matrix. And then we have to specify how you will be populating this matrix. So would you be populating it like, let me write, I'll be show it on Excel how to do that. Let me copy all these elements. And so number of rows are 2. So there will be 2 rows in the matrix. And number of columns are 3. So there'll be 3 rows. So we're talking about a matrix which is very much like this highlighted portion on Excel. Now how the data going to be populated in this? Would it be like 1 over here, then 2 over here, and then 3 over here, and then 11 over here, 12 over here, and 13 over here? Would it be like this? Or would it be like 1 over here, 2 over here, 3 over here, 11 over here, 12 over here, and 13 over here. Do we want it to be like this? So if we want it to be like this is called row type. And if we want it to be like this, it's called column. So in this case, row type will be by row will be true. In this case, by column will be true, or by row will be false. So here I'm saying by row is equal to true. That implies it will be populated like 1, 2, 3, 11, 12, 13. So let's see how it's populated. And along with that, I can specify the name for each row, and I can specify the name for each column. So that I do through a list. I create a list where the first element has a vector of 2 elements, row 1 and row 2, and then there's a second element which has all the columns in there, C1, C2, C3. So I enter, mdat is the name of the variable that has this matrix, and a matrix has been created. So let's look at that matrix. So this is a matrix that has been created. It has 3 columns, C1, C2, C3, which are coming from this piece of information. It has 2 rows, row 1 and row 2, which is coming over here. And if you look at the data distribution, it's 1, 2, 3, 11, 12, 13. It's exactly the way it was over here, because I made this by row is equal to true. If I make by row to be false, what's going to happen? Now it's different. It's 1, 2, 3, 11, 12, and 13. It is like this. So that is the reason why I wanted by row to be true, because I wanted my output to look like this. In case I want it to be a different way, like this, I'll make it to be false. So that is what I meant by the syntax. Okay, let's go to the next statement. Now, I showed you how to create a single contingency table where you take a frequency counts of distinct values of a categorical variable. However, you can make a two-way contingency table by looking at the distinct counts on the distinct combinations of the values of, in this case, rating and reviewer. So let's see what that means. Okay. So here, it will make a two-way contingency table on rating factor and the reviewer factor. So those who have forgotten about what rating factor was, let's go back to rating factor. So here's a rating factor. So it has 1, 2, 3, 4, 5, 6, 7 elements in there. So that's a rating. And reviewers has, reviewer has 1, 2, 3, 4, 5, 6, 7. So 7 reviewers, 7 ratings, and we want to find out for a given combination of rating and reviewer how many counts are there, what's a count. So once we do that, all that information is stored in T, and very quickly we get a two-way contingency table, which for unique combination of Bad and Ebert, how many counts are there? There are 2. For Bad and Martin, 1 review is there. For Bad and Rowan, there's 1 review in there. For Bad and Siskel, there's 0. Good and Ebert, there is no good for Ebert. Good and Martin, nothing. Good and Rowan, 1. Good and Siskel, 0. Worst and Siskel is 2, for others 0. So very quickly we can have two-way contingency table, and all it's doing is it's looking at the distinct values in the rating and the distinct values in the reviewers, and based on the combination it's finding out the counts in the data. So that's all it's doing, but this is a quick way in which you can do two-way contingency table. And the single-way contingency table is that if I have only one categorical variable in here, nothing comma and another one over here, it will do a single contingency table, which we already saw. So it's as simple as this one. So if I do this, if I do that, that's a single way contingency table. If I do this one, it is two-way contingency table. So that is what I meant by that particular syntax. Okay, so we are very close. So we have already done this one. Let's do the same thing what we have done so far, but let's do it in a different way. And the reason I wanted to do it in a different way because I want to expose you to the idea of cbind and rbind. So let's create another variable called ti, and here I'm going to do cbind. So the command is cbind whatever you want to bind together, those vectors. So in this case I want to combine rating and reviewers by column, and let me enter this. Now the rating and reviewer vectors have been combined together into a matrix, and that matrix has been assigned to ti. So now ti is a matrix. Let's see what is there in ti. Now ti is composed of two columns. The first column is rating, the other is called reviewer, and that is what cbind does. It takes two vectors, treat them as columns, and combine them as columns. Now if I do, let me create another variable called tr, and instead of cbind let me do rbind. Rbind stands for row bind. It will bind the two vectors as if they're rows. And let me do this one. And now if I call tr, you'll see instead of this vertical format, it is in a different format. It has rating in a horizontal way and reviewer in a horizontal way. So rating is one column, one row, and reviewer is another row. Here rating is one column and reviewer is another column. So that is what rbind and cbind does. Rbind will combine the vectors, treating each vector as a row. Cbind will combine the vector, treating each vector as a column. So that's the difference between rbind and cbind. So let's go to the next step. So I already created ti, which is out of cbind of two vectors. Now let me look at the class of ti. Whenever I do cbind and rbind, it creates a matrix. So the class is matrix. So that is fine. Now what I want to do is I want to convert this matrix into a data frame. Okay, how to do that? How to convert one variable to another? And for that, the statement, the syntax is right over here. Okay, so what the statement is doing is the keyword is as dot data frame. So all it's saying is that whatever ti is, convert that into a data frame. That's what the statement means. As dot, so whatever ti is, take that as a data frame and assign it to td. Okay, so let's do this thing, and now let's see the class of td. Td is a data frame. Let's do td, print the td. Now td looks way different from the way matrix was over here, ti. It's way different. It got all these beautiful names, rating, reviewer, 1 2 3 4 5 6 7 8 7 rows are there. Everything looks great. Now if I do table on td, it'll give me the same thing that I had when I was doing table on vectors over here, right over here. It gives me the same thing. This is a little bit more convoluted. The only reason I did that was because I wanted to tell you something about cbind and rbind and the fact that you can do table, a two-way contingency on data frame itself. Because when we're dealing with connection to the database or reading from the file, we end up creating data frames. So 90% of the time you'll be dealing with data frame. I just wanted to let you know that you can use table kind of functions on data frame, and you can create two-way contingency tables. It becomes really handy when you're doing data analysis. Okay, so far so good. So let's go back to our script. Another thing that we have to do is to define a function. Now at a very simple level you can have one-line functions, something like this, and I'll go through the syntax of this function. All it's doing is it's giving a name to the function. In this case it's going to be std, so that's the name of the function, and thereafter the definition of the function. So the keyword is function. It will always remain the same in material of what function you're writing. Thereafter this x is a parameter that you're passing to the function. So for example, you want to calculate the longest day in a given year, so you have to pass year in order to calculate the longest day. So the year is a parameter. So in this case x would be a parameter and if you give a number, say 1 to 100 to x, and that 1 to 100 is a parameter, x will assume that value, and thereafter SD is a way to calculate standard deviation in R. So it will calculate standard deviation on 1 to 100. And let's enter this. Now std has become a function. So if I create a variable, let me create a variable that has 1 to 100 number in there. So if I do v, it will have 1 to 100. That's what this notation means. This colon means give me all the numbers from 1, starting from 1 to 100. And then let me call that function std v. It will calculate the standard deviation on 1 to 100 number. So creating a function is as easy as that. The keyword is function, then you have to pass parameter in case you have any parameter, and then what operation you're going to be performing on those parameters. So that is all great. If I make v to be x to be or v to be something else, say give me random uniform distribution from 1 to 100 numbers. In this case, v will be like 100 uniformly distributed numbers, and I can do the same thing. This is the standard deviation of those 100 numbers. Similarly, if I want v to be random normally distributed numbers, I can do this, and I can do stv of v, and now this is the distribution. This is the standard deviation of normally distributed 100 numbers. So as simple as that. And if you want to see like what v is, and this is v, it is normally distributed. The previous one was a uniform distribution. So those are a few more commands. I do not have that in the lab session, but it's good to know. Okay, so let's look at more verbose functions. So the previous function was fine. It was just one liner, but usually functions are more complicated than that. So this is the syntax for writing a bigger function. Now here the keyword is function, and then you're passing the parameter just like the previous example, but this is a much bigger function. And then in this function I'm doing a bunch of things. I'm using a function called paste in R, which is used for concatenating strings. So one string is type of, another string is x, which is the parameter, and another string is and then type of x. So I'm going to calculate the type of x, what kind of x it is. Is it numeric? Is it character? And then I'll separate it by a space. So that's what SEP stands for, separator. And then I'll do the same thing in the second step, but instead of calculating type of, I'm going to calculate class. And then I'll do the same thing. Instead of calculating class, I'm going to calculate the structure of the variable. In the fourth case, I'm going to find out the names of that particular variable. And every time I do that, I will print the output. So here I find out the name of the type of the parameter x. I'll put that into variable p1, and then I'll print the p1 out. Similarly, I'll do it for p2. I'll find out the x. I'll put that into p2 class of x, and then I'll print out p2. Similarly, for p3, I'll find out the structure. I'll put into p3, and I'll print the p3 out. Similarly, for p4, I'll find out the names. I'll put that in p4 and print the p4 out. Now in R, the last function, the last line that you execute in R in a function, that is what is returned out. I do not want to return anything after I've printed all the four things, p1, p2, p3, p4, and so I put invisible in there. So invisible means do not do anything. Just give me p1, p2, p3, p4. That's all I want from you. And that's all you had to do. So once you do that, your function is done. One thing to be noted is, since we have multiple lines, they are surrounded by curly braces. This is a way to tell R that this is a function. If you have more than one lines, you have to put curly braces. If you have just one line, there won't be any curly braces, as we saw in the case of standard deviation. So there are no lines in there in the standard deviation function. So here it is just like one line. But putting curly braces is a very good practice. So even if you have one line, do put curly braces. It's going to be really rare that you're going to be writing a function that has only one line into it. But still, if you have multiple lines, put curly braces. If you have just one line, curly braces are not required. Let's enter this and see what happens. Okay, so tell me has been created. Now let me see if say ratings is one of the variables that we already have. It has 7 elements in there. So what tell me does to ratings? So now it gives me all those kind of things. Type of versus character, type of versus character, type of bad is character, and all the information, all the 4 things that we wanted um, out of that parameter over here are being executed on rating. So the point is, this is how you write function in R, and this is the basic syntax. If you have just one line, you do not need curly braces. If you have multiple lines, you need curly braces. The last line of the function will be printed out. If you do not want that to happen, put invisible parentheses, open parentheses, closed. And in function, you can have a bunch of other functions which you can combine together. Functions are useful if you're doing certain things again and again and again. So instead of doing that again and again, you can put that, bunch that together in one function and just call it function. That becomes so much more efficient. So function is nothing but a way to make things efficient in terms of execution. Okay, let's go to the next step in our lab. So the next thing that I talk about in the lab is how to install packages. So R is very much like the tools that you get from Menards or Home Depot, where say for example you have drill, and drill doesn't have just one bit, it has multiple bits. So depending upon what kind of job you're doing, you'll keep changing your drill bits. If you want to drill into concrete, you're going to have a different drill bit versus if you want to drill into wood. So R is very much like that. Depending upon your job, whether you're doing association rules or you're doing cluster analysis, you're doing some graphical analysis, you will need different packages. They're just like drill bits. So before you start doing association rule or any graphical analysis, you'll have to install all the packages related to that particular technique. So the syntax for installing the package is as simple as that. Install the packages, double quotes, and the package name. And here the package name I'm trying to install is Rattle. So it has double quotes and the name is Rattle, and install the packages, enter, and now it will go to the internet to make sure you're connected to internet. It'll find out all the things that are required for Rattle to work, all the dependencies, and whenever it asks for, like, do you want to install, do you allow us to install this particular thing, always hit yes, 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 and it will just install all the stuff. Okay, so now it seems like Rattle is installed, the Rattle package is installed. Now even though I've installed the package, still it's not going to do anything to me. So if I call one of the functions which are there in Rattle, it'll say could not find function Rattle, because you have to call the library first. So the library will load all the functions which are related to Rattle. So library Rattle, and now all the functions which are there in Rattle are loaded. Okay, so now all the functions are loaded. Now if I issue Rattle command, now there is no problem. It will open up the window, and so it opens up the window. So this is the Rattle interface which comes out of that command. So let's go back to our first lab. So we have already done the calling the Rattle. Similarly, we can also install package like our PostgreSQL that we'll be using to connect to Postgres database. So the idea is as simple as that. Install our packages, the name of the package surrounded by double quotes. Do not forget double quotes, and the fact that R is a case sensitive language. Once you do that, our PostgreSQL is getting installed. It downloads certain things, and now it's all done. Now still, if I do it will say could not find function dbconnect. So even though I installed our PostgreSQL, I haven't called the library our PostgreSQL, it cannot find all the functions which are required in order to do something like say dbconnect. So I have to again do library, and then name of the function, and then do just enter, and thereafter all the stuff that is required for our PostgreSQL is now loaded. All the functions are loaded. So now it will understand all the functions that are related to our PostgreSQL. So let's execute this particular command, which is to connect to the PostgreSQL server that is run by Loyola. Okay. And now connection established. Still taking time. So now connection established. So connection established. All I have to do is to do a small test to make sure that everything is working fine. And in this, what I'm doing is I'm calling that connection that I created in the previous step. I'm executing the SQL statement, select star from test, and I'm using this function of our PostgreSQL called db-get-query. So db stands for database. Get this query result from the database using this connection, and this is the query. And whatever the result is, put into this variable called myTable. So let's enter this, and the variable myTable has been created. If you do myTable, it will return you 3 rows in there because there is only 1 column in there. So that is how it works. Let's just let me walk you through that db-connect function. So in db-connect function, the first part is which particular database you're connecting to. So it's always going to be PostgreSQL because our PostgreSQL package is meant for PostgreSQL. The DB name going to be INFS494. Again, be cognizant of the fact that R is a case-sensitive language. Capital INFS494 is not going to work. Host is 147.126.64.66. This is a unique identifier called IP address of the host of the machine on which this database is running. Port is that particular port on that machine that database is listening on. And the user is data miner 1. You can put whatever I've assigned you to. And the password is fall 2015. One thing to be noted is that it's surrounded by double quotes, and all these parameters are separated by commas. So be cognizant of the fact. So that is the way you connect to a database. This is how you install different packages. Now one thing that you can see is that if you do class on myTable, it will be a data frame, and that goes back to the point I was trying to make earlier, that data frames, whenever you connect to database or read from the file, data frames are created by default. The variable would be data frame. So that's the reason why it's a data frame. Now another thing is you can also see this particular command called str, structure, and you can give the name of the variable, in this case myTable, and it's saying is that there is only one column called fname, and it has values. 3 observations are in there, and it's of type character, and the values are 1, 2, and 3. So that's all structure tells you. It gives you the structure of the variable of the data frame. How many columns are there, how many rows are there, what kind of columns are there. Okay, now another thing is that how to call, so this is a data frame, how to call a particular column of a data frame. So the way to do that is, this is a data frame, give a $sign, and then whichever column you are interested in. In this case, this particular table has only 1 column, so just select 1 column, and these are all the values of that particular column, fname. Now what if I'm only interested into the second row of this particular column in this data frame? How to do that? So the way to do that is, this will give me all the rows for a given column, is to type say 2, and this will give me the value 2 over here, right over here, which is a second row of column fname. So this is what it's doing. myTable fname $fname, that is second column, the column fname, and then 2 means the second row. So this is a way by which you can get the second row of the column fname. Now similarly, if I go for some other table, so let's go for the table, there's a connection, but db-connect. So I'm going for another table just as an example. And so now myTable has all the content which is there in grocery vertical. So myTable and $sign, and tells me there are 2 columns in this table. TID and regex split to tables. So if I do TID, it'll give me all the TIDs for all the rows which are there in the table. However, I'm only interested into the fourth row, and the fourth row is 1. If I do fifth row, is a fifth row. So it's giving me the fifth row of the column TID. I can also do something like this. Fifth row and first column. So that is again 2. So that is another way of looking at it. If I do this, what it's saying is first row of the fifth column, but there is no fifth column, and that's the reason if I do that I'll get null. So if I wanted to get second row of the second column, it'll give me semi-finished bread. It's the second row of the second column. If I want third row of the second column, it'll give me